Hi folks, today we're going to talk about slopes and equations of lines. I know this is geometry and slopes and equations of lines seem very much like an Algebra 1 or an Algebra 2 thing. There is a lot of review, but because we talk about parallel lines and we talk about perpendicular lines in geometry, we need to make sure that we've got the algebra to back up our knowledge. So today we're going to review a little bit. The first thing that we're going to review is the definition of a slope. Slope, or m, as it's written in an equation, of a line is the ratio of the rise. Ooh, let's try a different color. Sorry about that. All right, so it's the ratio of the rise to the run. In algebra, you'll remember that we talked about slope as rise over run. If you have 2 points labeled x1 and y1, x2 and y2, on a line, then the slope of the line is going to be the slope formula. So you'll find this on a formula chart. M equals y2 minus y1 divided by x2 minus x1. This is one of the first formulas that you guys memorize along with the Pythagorean theorem. And so this is the slope formula. Something that I want to mention that's a little bit more advanced is that sometimes, let's see, there, sometimes you may see this. You may see this. And if you see this, it'll generally be laid out in the form of a fraction. The way that you say this is delta y over delta x. So that little triangle is the Greek letter delta, and it means change. So what this literally translates to is the change in y over the change in x, which describes the rise and the run. So delta y over delta x means the change in y over the change in x, and that is the rate of change. That's the slope. That's the rise over run. So it's all connected. And I wanted to make sure that you've seen that little triangle before we move on. So in example 1, it says determine the slope of the line if point A is at 8, -3 and B is at -4, -2. So if I am determining the slope, that's m, I need to start off in pre-AP with a plan. My plan is my formula, y2 minus y1 over x2 minus x1. That's my plan. And this means absolutely nothing if I don't have y2, y1, x2, and x1. So I need to make sure that I label. This will be point 1, so this will have my x1 and my y1. This will be point 2 with my x2 and my y2. No, it doesn't matter which one is the 1s and which one is the 2s as long as they're clustered together. So y2 is -12 minus y1, which is -3. I'm going to make that plus 3. Over x2, which is -4, minus x1, which is 8. So -12 plus 3 is -9, and -4 minus 8 is -12. Those symbols kind of cancel, and when you simplify by 3, you get 3/4. That's your m value. And I made sure to put equals m to remind us that our m, our slope, is our answer. So we've talked about parallel lines. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope, but they have to have different what? They have to have different y-intercepts. If they have the same slope and the same y-intercept, that just means that they're the same line. So if they don't have the same y-intercepts, then they would be parallel. Otherwise, they're the same line. And we don't want coinciding lines, we want parallel lines here. It's also worth noting that any two vertical lines are parallel. Any two vertical lines are parallel. And also any two horizontal lines are parallel for that matter. So let's talk about perpendicular lines. Perpendicular lines in a coordinate plane, two non-vertical lines are considered perpendicular if and only if, biconditional, if and only if the product of their slopes is -1. So if you take both of their slopes and you multiply them together and you get -1, that means the lines are perpendicular. The other way to decide if your two lines are perpendicular is if you have slopes that are negative reciprocals. So negative reciprocal slopes. An example would be 4 and -1/4. Oops, there we go. One is positive, one is negative. One is 1/4, the other one is 4/1. So we have negative reciprocal slopes. It's also worth noting that vertical and horizontal lines are perpendicular to each other. They are perpendicular to each other always. So let's move on to example 2. It says find the value of y, that's what I'm finding, value of y, that satisfies the given conditions. The line containing -4, 9 and 4, 3 is parallel. What does parallel mean in terms of algebra and equations? It means it has the same slope as the line containing -8, 1 and 4, y. Oh, this is the y that we don't know. That's what we're finding. So I need to find the value of y that satisfies these conditions. If these two lines have the same slope, well, perhaps I can figure out what the slope is and I can solve for y. So let's start out with our slope formula, our plan. y2 minus y1 over x2 minus x1. That's our plan. Good thing to write it. And in my first set of points, I have x1, y1, x2, y2. So 3 minus 9 over 4 minus -4. 3 minus 9 is -6. 4 plus 4 is 8. And if I simplified it, I would get -3 over 4. Now, this is supposed to be equal to my other slope. So if this is x1, y1, and this is x2, y2, and I substitute those values in, I would have y minus 1 over 4 minus -8. My denominator is 12. And that's supposed to be equal to this 3/4, or this -3/4 that we kind of simplified to. But I need, in order to compare, fractions that have the same denominator. If this denominator is 12, then I need this denominator to be 12. So I want to multiply by 3 and multiply by 3. So -9 over 12. Well, my denominators are both 12. My numerators should be equal, but they're y minus 1 and -9. So if I can solve for y, then I'll be able to answer my problem. Y has a value of -8. That is the y value that makes the slope -3/4. So we compared the, there we go. We compared the numerators once we had the same denominator. And that's how we got this equation. Okay. So let's scroll down to the next page. Example 3 says, use the slope to determine whether the lines are parallel, perpendicular, or neither. Maybe they're just two lines floating in space with no special relationship. Line UV and line XY for all of those points. So if I'm talking about line UV, that includes these 2 points. If I'm talking about line XY, that includes these 2 points. So it might be a good idea, if I need to tell if the lines are parallel, perpendicular, or neither, to find their slopes and compare them. If the slopes are the same, lines are parallel. If the slopes are negative reciprocals, then the lines are perpendicular. If the slopes don't have either of those relationships, then they're neither parallel nor perpendicular. So let's try this out. y2 minus y1 over x2 minus x1. This is negative 3 over negative 1, or just 3. So there's the slope of line UV. For the slope of line XY, we have y2 minus y1 over x2 minus x1. This is a 2 over negative 6, which is negative 1 over 3. So I'm supposed to be comparing this slope and this slope. Well, they're definitely not the same, so those lines can't be parallel. But let's see what happens when you multiply them together. So when I multiply them together, 3 times negative 1/3 is equal to negative 3 over 3, or just 1. So because these two slopes have a product of negative 1, and 3 and negative 1/3 are negative reciprocals of each other, therefore, and by the way, if you do not know this, 3 little dots in the shape of a triangle in math mean therefore. So I have this statement and then I'm making my conclusion. So 3 and negative 1/3 are negative reciprocals. Therefore, I would say that line UV and line XY are perpendicular to each other. Remember, the symbol for perpendicular is an upside down T. So there is my answer. I'm going to move on to example 4, but I'm not going to move this up because I want you to have example 3 on your screen. Example 4 says, use the slope to determine whether the lines again are parallel, perpendicular, or neither. We're talking about line AB with points A and B, and line CD with points C and D. So what I'd like for you to do is pause your video and try out this problem. Check back whenever you have the answer. All right, folks. So hopefully, and probably, you all got that line AB is parallel to line CD. However, once you got that the slopes were the same, that they were both -4, you cannot stop there and conclude that those two lines are parallel, because it is always possible that even though those two lines have the same slope, they might be the same line. So you have to check and make sure that the y-intercepts are different. So what I did, and you can do this with slope-intercept form like I did, or you can do it with point-slope form if you're more comfortable with that. But I wrote out my slope-intercept form, y equals mx plus b. I put -4 in place of m, and I picked an x and a y from my line, and I substituted them in. So you can see that I used point A in the first equation. So I have 1 equals -4 times 2 plus b, and when you solve, you get a b value of 9, so that's the y-intercept. In the second line, I took my slope of -4, I picked point C, which was 4, 2, and I plugged in the 4 for x, the 2 for y, the -4 for the slope m, and I solved for the y-intercept and I got 18. Notice that both of those are different, which means that even though the lines have the same slope, they have different y-intercepts, so they're different lines. And those lines are actually parallel to each other. And I tried to squeeze that in the corner, but hopefully you're able to see the rest of the explanation, that that's because m is the same for both of these lines. Okay. So now we move on to the forms of the equation of a line. So we've got point-slope form, which I mentioned, and slope-intercept form, which I used. In point-slope form, m is still the slope, but x1 and y1 make up a given point. Any given point. So there's lots of different versions of point-slope form for the same line, because there's lots of different points that you can use. For slope-intercept form, there is only one version of that equation for the line. M is still the slope, but B is the y-intercept. Remember that the y-intercept is always going to be 0, and then some value for that y-intercept. It's also worth noting, if we're talking about equations of lines, that vertical lines and horizontal lines look a little bit different when it comes to their equations. Vertical lines have x equals some number, and that number is also the x-intercept. So if I'm talking about the vertical line, let's say, let a equal 2. So 2 is the y-intercept of this vertical line. So here's 2. I said y-intercept, I meant x-intercept, I'm sorry. So 2 is the x-intercept of that vertical line. So if you had a graph that looks like this, the equation would be x equals 2. Okay? In a similar sense, if we're talking about a horizontal line, the equation is y equals b, where b is the y-intercept. So let's say that your y-intercept is at 3, and you've got a horizontal line going through a y value of 3. Well, then your equation is y equals 3. So that's what your equations of vertical and horizontal lines look like. And this is just a reminder from Algebra 1 and Algebra 2. So if you remember them, that's awesome. If you don't, you may want to rewatch that part. And we're on to our last page of our notes today. So in example 5, it says write the equation of each line in slope-intercept form. Slope-intercept form should be written up here as a reminder of what your answer should look like. Now for slope-intercept form, I need the slope and I need the y-intercept. That's why it's called slope-intercept form. So it gives me a line through 2 points, an x and a y, an x and a y. So with that, I can find what? The slope or the y-intercept? Find the slope. So 9 minus -6 over 8 minus -12 is 15 over 20. And if I simplify both of those by 5, I'm going to get 3/4, which is great. So now, since I don't have the y-intercept, I'm going to take my slope and perhaps one of my points that doesn't have negatives. I think that might be easier. And I'm going to substitute those values into slope-intercept form. So instead of y equals, I have 9 equals. Instead of m times x, I have 3/4 times 8, because x is 8, plus b, the value that I don't know. So 9 equals, 8 divided by 4 is 2, and 2 times 3 is 6. So that's that product right there. And to isolate b, you want to subtract the constant. So your b value is 3. So when I put all of this together in slope-intercept form, I have y equals 3/4 x plus 3. Okay. Part B asks you for something pretty similar. I'd like for you to pause the video and try this one on your own. Check back for the answer after you've worked it out. Getting the slope was probably the easy part. 3/5 is your slope. When you substitute your slope and the x and y value from a point into slope-intercept form and you solve, you're going to end up having to do some fraction work. So the first fraction work that you have to do is 3/5 times 8. 3/5 times 8 means 3 times 8 on the top, and 5 is your denominator. So 3 times 8 is 24. That makes 24/5. When you subtract 24/5 from both sides, you end up with 10 minus 24/5, but you can't subtract 10 minus 24/5 unless the 10 has a denominator of 5. It's got to match. So in order to get that fraction, you take 10 and you multiply it by 5. 10 with a denominator of 5 would be 50/5. You subtract 24/5 from it. You end up with a resulting 26/5 for your b value, and you rewrite your equation. So if you need to, you are welcome to pause your video, try again, really look through that work with the fraction, and I'm going to scroll down to our next example. So in example 6, we have part A and part B. We'll do part A together, and part B you'll do on your own. It says write the equation of each line in point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1. And it gives us 2 points. So you can use one of the points for your x1 and your y1, but you need to use both of them to calculate your slope. So perhaps pause the video and calculate your slope without me. Now that you have your slope, you get to decide which point you're going to use for your x1 and your y1. I'm going to use both of them, and that way you get the idea of which equation kind of looks the way that you want it to look, but both of them will be correct. So your point-slope form starts out with y minus y1, so let's use this as y1, equals m times x minus x1. So there's one option. Your second option is y minus, let's use this as y1. So if you subtract -4, that's really plus 4, equals m, same slope, times x minus x1. So either of these equations is acceptable. So now I'd like you to move on to part B. Part B, I want you to try by yourself, pause the video and work it out yourself. Remember that with the information that's given, you should probably create 2 ordered pairs to work with. All right, folks, so go ahead and check your answers. An x-intercept of 3 is the ordered pair 3, 0. A y-intercept of -5 is the ordered pair 0, -5. Be mindful when you use point-slope form that the formula has y minus y1 and x minus x1 in there. So whenever you put your x and y values into your equation, you're going to have to change their original signs because you do have that minus happening in your formula. So I have both of your possible answers there. I'm going to scroll down to our last 2 examples for the notes today. Example 7 says graph the following lines. We have part A that has slope-intercept form. And we have part B that has point-slope form. So I'm going to do part B with you, and then you can do part A on your own. For part B, our slope is 2/5, but that means nothing unless we have a place to start from. So we're going to go ahead and write down our ordered pair that we get from x1 and y1. The x1 value is 2, not -2, but 2, because our formula is x minus x1. So if I have x minus 2, then 2 is my value. And my y1 value is 3. So instead of starting from the y-intercept, here I'm going to start from the point 2, 3. My slope is 2/5, so I'm going to rise 1, 2. I'm going to run 1, 2, 3, 4, 5 off of my graph. I need to extend the line backwards, so I'm going to go down 2 and back 1, 2, 3, 4, 5. And in Cami, I can go ahead and use my Shapes tool to graph my line. Beautiful. Make sure you include some arrows on there. So what I'd like for you to do is pause your video and try example 7 on your own. It should be quite a bit easier. And finally, for 7a, make sure you start at a y-intercept of 1, and your slope is -3/2. So instead of going up 3, since it's negative, you're going to go down 3 and to the right, and down 3 and to the right. Use the Shapes tool to write a straight line, and then make sure you include those arrows.